How much larger is the Sun compared to Earth? How many planets with the size of Earth could fit inside the Sun's vast expanse? And what are the differences in age, rotation period, temperature and magnetic field? Let's go straight to the comparison and examine a mysterious phenomenon on the Sun that has puzzled scientists to this day. The Sun's mean diameter is approximately 1,391,400 kilometers. With a diameter of approximately 12,742 kilometers, Earth is considered a medium-sized planet in our solar system. The vast difference in their diameters illustrates the staggering scale of the Sun's dominance over Earth, with approximately 109.2 Earth-sized planets fitting snugly within its huge expanse. The mass of the Sun is approximately 1,988,500 times 10 to the power of 24 kilograms, while the mass of Earth is roughly 5.9724 times 10 to the power of 24 kilograms. This means the mass of the Sun is about 333 times greater than the mass of Earth. This comparison highlights the overwhelming scale of the Sun compared to Earth, emphasizing its pivotal role in shaping the dynamics of our solar system. Notably, the Sun contains 99.86% of the mass of the entire solar system. The circumference of the Sun is approximately 4,370,000 kilometers, while the circumference of Earth is roughly 40,075 kilometers. Therefore, the Sun's circumference is approximately 1,009 times larger than Earth's, mirroring the ratio of their diameters. The surface area of the Sun is approximately 6.09 times 10 to the power of 12 km squared, while Earth's surface area is approximately 5.1 times 10 to the power of 8 km squared. Therefore, the Sun's surface area is approximately 11,941 times larger than Earth's. The volume of the Sun is approximately 1,412,000 times 10 to the power of 12 kilometers cubed, while the volume of Earth is about 1.083 times 10 to the power of 12 kilometers cubed. This indicates that the volume of the Sun is roughly 1,304,000 times greater than the volume of Earth. Consider that you could fit approximately 1.3 million Earths inside the Sun. This staggering difference leaves one in awe of the vastness of the Sun compared to the relatively diminutive Earth. Now let's compare the density of these celestial bodies. Here things take a slight turn. The Sun is primarily composed of hydrogen and helium gases, while Earth is a rocky planet. The striking disparity in mean density, with the Sun's density at 1,408 kilograms per cubic meter compared to Earth's denser 5,514 kilograms per cubic meter, reveals an intriguing ratio of approximately 0.255. This stark contrast underscores the much denser composition of Earth compared to the Sun. The Sun's age is approximately 4.6 billion years old, having formed from the gravitational collapse of a region within a large molecular cloud. This age is determined through radioactive dating techniques. Earth's estimated age is about 4.54 billion years, making it slightly younger than the Sun. The Sun exerts a gravitational force with a value of about 274 meters per squared second at its surface. Earth's gravitational force is approximately 9.81 meters per squared second at its surface, crucial for keeping objects and living beings anchored to its surface, creating the cessation of weight and providing the necessary conditions for life to thrive. Therefore, the Sun's surface gravitational force is approximately 28 times stronger than that of Earth's. While surface gravity affects objects on or near the surface, it's the Sun's mass and gravitational attraction that keep planets in orbit around it, maintaining the stability of the entire solar system. Let's compare their rotation periods. The sidereal rotation period of the Sun is approximately 25.38 days, or about 609.12 hours. Earth completes one rotation in about 23.9345 hours. This highlights a significant difference in their rotation periods, with the Sun's rotation period being 25.449 times longer than that of Earth. Comparing the temperatures of the Sun and Earth reveals an unsolved cosmic mystery. The core temperature of the Sun reaches 15 million degrees Celsius due to nuclear fusion reactions, whereas the core temperature of Earth is estimated to be around 5,000 degrees Celsius. The surface temperature of the Sun is approximately 5,505 degrees Celsius, while the surface temperature of Earth varies but averages about 15 degrees Celsius. It ranges from approximately minus 102.2 degrees Celsius to 52.7 degrees Celsius. The temperature of Earth's atmosphere has fluctuations. At Earth's surface, the typical temperature is 15 degrees Celsius, while in the troposphere the temperatures generally decrease with altitude to minus 15.1 degrees Celsius at the tropopause. In the stratosphere, temperatures generally increase as altitude increases, potentially reaching near 0 degrees Celsius. Moving upward into the mesosphere, temperatures decrease with altitude, reaching their lowest point at the mesopause. This region is known as the coldest place on Earth, with an average temperature of around minus 85 degrees Celsius. Ascending further into the thermosphere, temperatures gradually rise with altitude and can reach as high as 1,500 degrees Celsius, while the exosphere experiences varying but typically high temperatures. And now let's explore the unsolved mysterious phenomenon I mentioned earlier. The upper layers of the Sun's atmosphere exhibit temperatures thousands of times higher than those found on its surface. Surrounding the Sun, the outer atmosphere or corona reaches temperatures of around 2 million degrees Celsius, with certain regions soaring as high as 20 million degrees Celsius. This enigmatic phenomenon, known as the solar coronal heating problem, continues to perplex scientists worldwide awaiting discovery. Recent research suggests that this puzzling disparity in heat could be attributed to faint yet persistent waves propagating within the area. The Sun's magnetic field is stronger, with a strength of approximately 1 Gauss at its surface. Earth's magnetic field measures around 0.5 Gauss at its surface. In comparison, a robust refrigerator magnet typically has a magnetic field strength of around 100 Gauss. While the surface magnetic field of the Sun may only be twice as strong as Earth's, its influence extends far beyond its immediate vicinity. This is because the Sun's magnetic field is not only stronger, but also much larger and more dynamic. It generates powerful solar winds and solar flares that propagate throughout the solar system, affecting the space weather and magnetic environments of all the planets, moons, and other celestial bodies within its reach. So, even though the difference in strength may seem modest, the Sun's magnetic influence is vast and far-reaching due to its scale and activity. The comparison between these two celestial bodies showcases the breathtaking difference between our humble home planet and the Sun, which stands as the dominant force in our solar system. If you want to witness the mesmerizing movements of the Sun over 133 days in a captivating time-lapse, along with more intriguing details about our closest star, then be sure to check out this video. See you there!